Good day, this is Train of Thought Science. This is my genius son Isaac. My name is Shannon. And tonight we're going to be talking about the Van Allen belts. Some of the bullet points we'll be hitting on is number one, defining what they are. Number two, we're going to be talking about some conspiracy theories and why we didn't go to, stating that we didn't go to the moon, and Van Allen belts being one of the excuses. Isaac, what else?
Ionization in the upper atmosphere, Aurora Borealis, and how it's caused by the Van Allen belts. And just for an addition, shuttle launches, why we do it from Houston and Florida. Cape Canaveral.
Right. Definition?
Van Allen belts, as you can see here, there are usually two of them. We'll get back to that later. They're composed of charged particle radiation. Most people think radiation is something harmful like X-rays or gamma rays, something that kills you and melts you.
Which is going to be part of the definition as to why we were able to get around them okay when traveling to the moon. And usually they're 1,000 to 60,000 miles out. I have a very large head. Anyway.
Yes. Most people think radiation, they're thinking of the electromagnetic spectrum that contains X-rays, gamma rays, and radio waves and other things. Radio waves aren't too harmful, especially not as harmful as X-rays. But this is actually charged particles that are created by a process called ionization, which can sometimes be created at a high temperature, which is plasma. Plasma is ionization. That's another state of matter. So.
And common point, what on earth is made of plasma?
Fire.
Fire. Fire is a type of plasma. And also, lightning? Is lightning a type of plasma?
I'm not sure. Maybe because electricity is electrons. Mm-hmm. And the electrons would have had to have been separated.
We're not sure. That just came to my head. Okay.
Okay.
But this is related to the conspiracy theories and the definition of what it is. On to the conspiracy theories, conspiracy theorists trying to state that we didn't go to the moon because we had to go through the Van Allen belts and it would have killed our astronauts.
Haven't defined ionization.
Okay, great.
Ionization is how the charged particles occur. Ionization is the separation from the atomic nuclei from the electrons. Okay, so the conspiracy theory.
We didn't go to the moon.
They say that we launched here and came up through the radiation belts, and the orange is the most concentrated part, and we just went straight through and got huge doses of radiation. This is not true. For one, we could just take a path around the radiation belts, not completely around, but we find the weakest points in the radiation belt. And for another, because it's a less damaging type of radiation, and two, because of our hull and the precautions that we have taken, the hull being the cover of the ship.
Yeah, and being made of stainless steel, aluminum, and
polyethylene and an epoxy heat shield.
All of which blocked certain types of radiation.
Yes. Polyethylene blocks the charged electrons, and then aluminum and the epoxy heat shield blocks the protons.
So you don't exactly need lead to block X-rays because there are no X-rays in the Van Allen radiation belt.
Yes.
And good time to little factoid. Why, Isaac? Why do we launch from Cape Canaveral in Houston, Texas?
Okay, so Cape Canaveral. Where's the map? This is actually of the other side of the world. I was going to point to it, but Cape Canaveral and Houston are around the equator here.
They're not on the equator, but they're the continental United States. That's the closest points in which we have to the equator.
Yes. And because it's at the equator, there's a greatest angular velocity, which is just how fast it's going in a circular motion. And what direction it's going, because velocity is speed and direction. So we launch from here because of the centripetal force is greatest at the equator, Centripetal force is an outward force generated by rotational motion. So that's why if you swing a ball on the string, it stays the maximum distance it can without snapping the string.
And you let go of it, and that's going to be your hypothetically your equatorial region is going to be the center point of the line at which you launch a ball at the end of a string. You're going to have the most momentum taken off from the equator,
Yes,
as opposed to closer to the poles.
yeah, most momentum possible.
Speed, and what is the escape velocity?
Escape velocity.
Velocity, yeah. Okay.
Escape velocity, the definition is not the actual Maritime Webster Dictionary definition, but it is how fast you have to go to be able to escape the gravitational field. That is 17,500 miles per hour.
Okay, well, nice factoid. Aurora Borealis.
Have we finished the conspiracy?
No, we didn't. No, we didn't. The conspiracy. So, when we launched to avoid the most intense parts of the Van Allen radiation belts, we simply went around the weakest points of the Van Allen radiation belts to get to the moon. So our radiation dose was much, much less than it would have been.
Also considering that radiation is an accumulative factor and possibly exponential, this means that if you're exposed to radiation and then your body starts trying to repair itself while it's still being bombarded with radiation, that is extremely harmful. And when your body's harmed even more, it tries harder to repair itself, which causes it more harm. We'll pause in a minute.
Yeah, it's almost a multiple effect. As the longer you're in it, the damage that you receive almost multiplies. If you're, for example, the Apollo 11 astronauts total, they went through the Van Allen radiation belt 6 hours. Going to, it was 3.5 hours, and they spent a couple days on the moon, then came back with plenty of time to recuperate. Then they came back and spent 2.5 hours going through the radiation belts, which made a big difference as opposed to 6 hours. And the total radiation which they received both times through was much less than your average person working with nuclear materials here on Earth. I'm not talking, it's in the United States, it's moderately low radiation levels that they received, doses.
Yes, and the shielding, we're going to go back to lead blocking X-rays. Lead can block...
Factoid.
Yes, a factoid. A fact. Lead does block X-rays, but then it creates more secondary X-rays on the other side. This is the Bremsstrahlung effect. And that's 2 S's and an H before the L.
Yes, quite spelling with the lung at the end.
Yes.
Okay. Are we ready for Aurora Borealis?
Yes. So you see how they come, I'll have to turn around. See how the two come together here near the equators, not the equators, but the ends of the prime meridian, the poles, that's what I'm looking for, the poles. They come together at the poles and the radiation is diffused across the belts, and they go into the poles and intersect the atmosphere, causing a refraction of light with the charged particles.
Okay, was there anything else that we wanted to speak on tonight?
I don't think so.
We covered quite a bit in a short time. Anyway, that's it for tonight. This has been Train of Thought Science. Have a good night. Talk to you again.